Welcome back, friends. So in the previous session we have started with one property, which is time differentiation property. Based on this, there is a question on GATE ESE 2015. ESE 2015. If f of t is equal to 2 root t by pi and f of s Laplace transform is equal to s power minus 3 by 2, then Laplace transform of g of t is equal to 1 by root 1 by pi t is option A 3 s power minus 5 by 2, option B s power minus 1 by 2, option C s power 1 by 2, option D s power 3 by 2. Okay. So if a question is given like this, that means a time domain expression is given and its Laplace transform is given. Another time domain expression they are giving and they want to calculate what is the Laplace transform. So from this we can conclude one thing: there may be some relation between f of t and g of t. With that relation we can calculate what is g of s. That's what it means. Okay. So first try to understand. Here f of t is given like this: 2 root t by pi. I want to write like this: 2 by root pi t power 1 by 2. T power 1 by 2. Next, g of t is given, that is 1 by root pi t. This can be represented as 1 by root pi t power minus 1 by 2. So if you observe carefully, what is the relation between g of t and f of t? That means how we can write g of t in terms of f of t. That means what is g of t is equal to in terms of f of t. If I could write like that, then we can calculate what is g of s directly. Okay, see here. If I differentiate this f of t, can I get g of t or not? Definitely. See, differentiation f of t by dt, that is 2 root pi 1 by 2 t power 1 by 2 minus 1. So that is nothing but 1 by root pi t power minus 1 by 2. Yes, this relation is valid. So once we know this relation, directly we can calculate g of s is equal to s into f of s. So f of s given as s power minus 3 by 2. So this is going to be s power minus 1 by 2. So this is what is the answer is. Clear or not? So just we have to see what is the relation between g of t and f of t. Once we know the relation, we can say what is the Laplace transform for g of s. Take it in S domain. Differentiation in S domain. That means, let's say, if x of t having Laplace transform x of s with ROC R, then what is the Laplace transform for tx of t? This is nothing but minus dx of s by ds. Yeah, and ROC does not change R. So if I multiply, let's say t power n times, then we have to multiply minus 1 n times d power n x of s by ds power n. Still ROC does not change, R only. Let's take one example. Laplace transform of R of t. Laplace transform of R of t. That's what we have to calculate. So for that, let's see. First we know u of t. For u of t, what is the Laplace transform? 1 by s with sigma greater than 0. R of t. What is R of t actually? That is nothing but t u of t. From the differentiation in S domain property, we have to do minus d by ds of 1 by s. D by ds of 1 by s. What is that? This is minus d by ds of s power minus 1. So it is minus into minus s power minus 2. That is 1 by s square. Still sigma greater than 0. So simply you can remember, for R of t, the Laplace transform is 1 by s square. Still sigma greater than 0. Laplace transform of this function. Try. T e power minus at u of t. For this function, what is the Laplace transform? Let's see. First we know e power minus at u of t. For this function, we know what is the Laplace transform. What is that? 1 by s plus a with sigma greater than minus a. Now t e power minus at u of t, then it is minus d by ds s plus a whole inverse, that is minus into minus s plus a whole power minus 2. So that is going to be 1 by s plus a whole square. Still sigma greater than a minus a. So you can remember this one directly as a formula. Directly you can remember this one. For the continuation for this, suppose if it is t power n times, t power n e power minus at u of t, having Laplace transform, directly remember as a formula, n factorial by s plus a whole power n plus 1, sigma greater than minus a. Remember, okay. X of s is equal to e power minus 2s d by ds 1 by s plus 1 whole square. Find x of t. Find x of t. Okay, so in a reverse order we have to go. Let's say first what we know, 1 by s plus 1 whole square. For this, what is the inverse Laplace transform? Which is nothing but t e power minus t u of t, right? T e power minus t u of t. E power minus t u of t having 1 by s plus 1. If t is multiplied with, this is the, what is the Laplace transform we are going to get. Now, d by ds 1 by s plus 1 whole square. So here, if it is minus there, we have to multiply with the t. But if it is not minus there, so we have to multiply with minus t. So this is going to be minus t square e power minus t u of t. Okay. Next, if it is multiplied with e power minus 2s, exponential multiplication in s domain, then time shifting, it is going to give you time shifting. So wherever t is there, that has to be replaced with a t minus 2. So minus t minus 2 whole square e power minus of t minus 2 u of t minus 2. So this is what the inverse Laplace transform for this function. Take it. And here one doubt we are having, why we have written a right-sided signal for this one? Why can't it be left-sided signal? Because nothing is mentioned. That means nothing is mentioned about the ROC. Then we can take right-sided ROC as a default. So if ROC is not mentioned, is not given, then default, by default, ROC is right-sided ROC. Question 4. If x of s is equal to log s plus 5 by s plus 6, obtain x of t. Obtain x of t. Okay, listen. First, it is a logarithmic function. We don't know what exactly we can do. But we can write x of s is equal to log a by b, can be written as log a minus log b. That is log s plus 5 minus log s plus 6. This is what we can write. From this, let's say, if I differentiate this dx of s by ds, what we are going to get? 1 by s plus 5 minus 1 by s plus 6. For this, we know how to write the inverse Laplace transform. Now, if I apply inverse Laplace transform on both sides, for this it is minus t x of t, minus t x of t. So if it is t x of t, it has to be minus there, but it is not minus there, so we have to keep minus here. So if nothing is mentioned, then we can write right side signal e power minus 5t minus e power minus 6t u of t. So we require x of t. X of t is equal to, if I bring this minus t here, e power minus 6t minus e power minus 5t by t u of t. So minus, keep it here, so that it is going to be this one first, this one next. Okay, so this is what x of t here. Take it. Time scaling property. What is this? Let's see. X of t, x of s with ROC R. Then x of at having Laplace transform 1 by mod a x of s by a. What will happen to ROC is equal to a into r. A into r. This is what it is going to be. Let's take one example. U of 2t minus 4. For this, I want to see what is the Laplace transform. First, we know u of t. This is going to give you 1 by s, sigma greater than 0. U of t minus 4, e power minus 4s by s, still sigma greater than 0. U of 2t minus 4, 1 by 2, wherever s is there, that has to be replaced with s by 2. E power minus 4 into s by 2 by s by 2. 2 get cancelled, 2 times get cancelled. Still sigma greater than 0. Why? See, if it is 0 is multiplied with a, it won't make any difference. So still it is 0. So finally what we are going to get? E power minus 2s by s. Take it. In the similar way, suppose if I take one more example, delta 2t minus 3. Delta 2t minus 3. For this, what is the Laplace transform? Let's see. We know delta t having a Laplace transform which is equal to 1, and ROC is entire S plane. Delta t minus 3, e power minus 3s, still ROC is entire S plane. Delta 2t minus 3, then 1 by 2 e power minus 3 by 2 s. This is what the Laplace transform. Clear? Take it. Next property, convolution in time domain. What is this? Let's see. If a signal x of t having Laplace transform x of s with ROC is equal to R1. Another signal x of h of t, h of s, ROC R2. X of t convolution with h of t. Then this is simply multiplication. X of s multiplied with h of s. What is ROC? This is R1 intersection R2. R1 intersection R2. That's what we are going to get. Okay. Let's take an example. E power minus at u of t convolution with e power minus at u of t. Actually, we know from the convolution, this convolution results into t e power minus at u of t. Okay. So can I get the same thing from the Laplace transform or not? We have to check. For that, let's see. If I take Laplace transform, what is the Laplace transform here? 1 by s plus a multiplied with 1 by s plus a. That is equal to 1 by s plus a whole square. 1 by s plus a whole square. For this one, what is the inverse Laplace transform? That is nothing but t e power minus at u of t. So this is what the inverse Laplace transform for this signal. Okay. So I know this is going to give you this result. Let's take one more example. E power minus at u of t convolution with e power minus bt u of t. So this is calculated from the integration method in the convolution, but this is going to be much simpler in the S domain. Why? Convolution becomes multiplication. Let's see how simple it is going to be. This is going to give you Laplace transform 1 by s plus a into s plus b. So if I take partial fractions, 1 by s plus a, cover up method, if I cover this one, if I place s is equal to minus a, then this is 1 by b minus a by s plus a, plus cover up method for s plus b, then it is a minus b, 1 by a minus b by s plus b. So if I take 1 by b minus a common out, then what we are left with? 1 by s plus a. Here it is 1 by a minus b, but we have taken common 1 by b minus a, so we are left with minus sign s plus b. So this is what we are going to get. Now for this, what is the inverse Laplace transform? If I take inverse Laplace transform for this, it is going to give you 1 by b minus a e power minus at minus e power minus bt into u of t. So this is what we are going to get. So this is going to be much simpler in the Laplace transform if you observe carefully. Clear? Take it. Question number 5. Laplace transform of f of t, which is equal to f of s, which is equal to s plus 2 by s plus 1. Laplace transform of g of t, which is equal to g of s, which is equal to s square plus 1 by s plus 3 into s plus 2. S plus 2. If h of t is equal to integral 0 to t f of tau g of t minus tau d tau, then h of t is so here by seeing this integral, let's say first I will give you a method, then I will tell you what is the wrong what we are thinking in it. Okay, what is the wrong we are thinking in it. Let's say solution. H of t can be written as, from this integral, this is nothing but f of t convolution with g of t, right? If I take Laplace transform on both sides, then h of s is equal to f of s multiplied with g of s. Then what is f of s? We know that is s plus 2 by s plus 1 multiplied with s square plus 1 by s plus 3 into s plus 2. So here, sorry, this is a s square plus 1. Please make a change. This is s square plus 1. S square plus 1. S square plus 1, s square plus 1 get cancelled. S plus 2 get cancelled. Finally, we are left with a 1 by s plus 3. So this is what h of s. Once this is h of s, then we can write h of t is equal to e power minus 3t u of t. That's it. This is the correct answer. But here, so many unknown things we have. That means, let's say first, why you have written a right-sided signal here? That is the one question. So you can say that, sir, nothing is mentioned about ROC. So by default, I have taken right-sided ROC. But that is not true because they have given ROC. Sir, where they have given ROC? Yes. It is in the form of integral limits. Why? See, actually, if you observe carefully, the integral limits must be minus infinity to plus infinity. Instead of that, they have given 0 to t. I told you, while we are doing the convolution, if convolution integral limits are 0 to t, that indicates both the signals, this is f of t and g of t, are right-sided signals, or we can say causal signals. And convolution of causal signal is again a causal signal. So convolution of two causal signal is again a causal signal. That's why h of t is a right-side signal. So without knowing these things also we got the right answer. But still you have to remember this. So I am just writing those points. If convolution integral limits are 0 to t, 0 to t indicates both f of t and g of t are causal, and convolution of two causal signals is again causal. So we know that causal convolution with causal is going to give you causal only. This is the things you have to remember. Take it. One more property, integration property. If a signal x of t having Laplace transform x of s, then integral minus infinity to t x of tau d tau having Laplace transform x of s by s, x of s by s. So this is what it is. Okay, take it. Find impulse response of a causal LTI system described by dy of t by dt plus 4y of t plus 3 integral minus infinity to t y of tau d tau is equal to x of t is equal to x of t. Okay, how we can do this? Let's say apply Laplace transform on both sides. Then what will happen? This is s y of s plus 4 y of s plus 3 y of s by s is equal to x of s. So if I take y of s common out, then s plus 4 plus 3 by s is equal to x of s. So what is h of s? Which is y of s by x of s. So cross multiply it. This is going to be s by s square plus 4s plus 3. That's what h of s we got. So once we got h of s, which is s by s square plus 4s plus 3. This can be factorized like this: s plus 3 s plus 1, like this. So once we factorize this, then we are having partial fractions which are like this: 3 by 2 1 by s plus 3 minus 1 by 2 1 by s plus 1. Now we have to simply find h of t. So h of t, to calculate h of t, that may be right side, that may be left side, but they have given one conclusion here, one clue here, that is causal. Causal means it has to be right side sequence. So directly we can write h of t is equal to 3 by 2 e power minus 3t minus 1 by 2 e power minus t into u of t. That is what h of t. So continuation for this one, if x of t is equal to delta t plus u of t, then find y of t. Find y of t. How we can calculate y of t? Okay. So never ever do that convolution once we complete the Laplace transform. Why? In the Laplace transform, convolution will become multiplication. So once convolution becomes multiplication, never ever do that convolution again. So directly go for the multiplication. For that, what we require? X of s. So from this we can say x of s is equal to 1 plus 1 by s. So that is s plus 1 by s. Now what is y of s? That is x of s multiplied with h of s. Y of s is equal to h of s multiplied with x of s. Then what is x of s? Just now we have calculated s plus 1 by s. What is h of s? That is here s by s plus 3 into s plus 1. S plus 1. So s plus 1, s plus 1 get cancelled, s get cancelled. Finally this is 1 by s plus 3. So once it is s plus 3, y of s, then what is y of t? E power minus 3t u of t. Okay.